A major topic we didn't address in our first video about linear functions is the graphs of linear functions. We started out our previous video discussing that linear functions are functions whose graph is a line, but then we didn't really focus on the fact that that line is the graph or the picture of the solution. So that's what we're going to look at in this video, is the graphs of these linear functions. And there's a couple ways we can approach these. The first way we're going to look at is how we can find the equation of a linear function from the graph. The idea is, if I give you the graph, can you give me the equation? Now, when we find the equation from a graph, we really need to know two things: the slope, or rate of change, and the y-intercept, or the starting point. When we want our rate of change or the slope, what we'll do is we'll look at m being equal to not y2 minus y1 over x2 minus x1, because we don't know what the points are. We just have the graph. Instead, we're going to count what is the rise over the run. The rise is how far we move up, and the run is how far we move right. So if we're moving left or down, we'll call those negatives. If we're moving up or right, we'll call those positives. Then all we need to do is identify the start value, or the y-intercept, is the b. So, for example, I have this graph here. And we're going to put a point at -3, 6. -3, 6 is a point. Then I'm going to put a point at 0, 4. Then I'll put a point at 3, 2. And the next point's going to be at 6, 0. And if I can connect all those points with a straight line, we should be able to pull off all the key points or pieces of information that we need to make the equation of this line. First, with the slope. We said the slope was rise over run. The idea is I can take any 2 points and connect them by making a triangle. We rise and run. Now, because I went down, we'll call that a -2 rise and a run of 3. Notice that's going to be consistent. It's always down 2 over 3, down 2 over 3. It doesn't matter which points I pick for that. So that's going to tell me that my slope is down 2 over 3, or -2/3. The other piece of information I need is the starting point, or the y-intercept. Now, the y-axis is the vertical line, and when we say y-intercept, we're talking about where the graph touches that vertical line. It looks like it touches that vertical line at 4. So that tells me that 4 is my b. And so if the equation is y equals mx plus b, like we saw in our previous video, then the equation of our blue line here is a slope of -2/3 x plus a b of 4. And now this is the line, the equation of the line, that has the graph that we started with. Let's take a look at another example. We're going to go the other direction. This time we're going to start with the equation and try and build the line. We're going to make the graph from the equation. And the idea here, the strategy here, is we're going to start at the y-intercept, which is b, and slope from there, which is rise over run. So for example, if we've got the equation y equals 1/2 x minus 3. Remembering that y equals mx plus b, I can identify really quickly that 1/2 is my slope. And slope is rise over run. So my rise is a positive 1, the run is a positive 2. B is my start value. That's going to give me everything I need to know in order to graph this equation. Okay, we said we would start with the y-intercept. The y-intercept is -3, so I'm going to cross the y-axis at -3. Then I'm going to slope away from there, and I'm going to rise 1 and run 2 to get my next point. And I can go another one too, rise 1, run 2, and I can get my next point. I could even go backwards 1 and backwards 2. As long as I go backwards on both of them, I'll get another point. And you start to see how these dots all come out to a perfect line with each other. And there is the graph from the equation. Now there's two special lines I want to take a look at. One of them technically works with what I've seen so far, and one of them doesn't really because there is no slope. The slope ends up being undefined. And these are what are called horizontal and vertical lines. Now a horizontal line is like the horizon, it's flat, and a vertical line goes up. And what I want to notice is while there is a 0 rise on a horizontal line, I can still run, maybe we'll call that 1 space. And so my slope is 0 over 1. The slope ends up being 0. And that's okay because we can take nothing and divide it between 1 unit and we get nothing. So with our horizontal lines, we basically just end up with the y-intercept. If I have a horizontal line running right through here, it's got its y-intercept at 2 up. And so this becomes the equation y equals 2. Because the slope is 0, rate of change is 0, it's completely flat, so it's just y equals 2. Now a vertical line is a little different because a vertical line does have a rise. Maybe we'll call that a rise of 1. But when we try and run, there's no run left or right, so we end up with a run of 0. And 1 divided by 0 is undefined. We cannot divide by 0, so it turns out we cannot write a y equals equation for this. And you can see why this is not a function. Remember when we started talking about functions, we said functions had to pass the vertical line test, where a vertical line could only cross the graph once. Here the vertical line crosses the graph everywhere because the vertical line is the graph. And so instead of using the y-intercept, we have to use the x-intercept. Say this is our graph. There is no y-intercept, but there is an x-intercept. At, in this case, -3. So we'll say x equals, because it crosses the x-axis, -3. And what you notice is on this vertical line, no matter where I am on the vertical line, x is always equal to -3. Hence the equation. Similar to the y equals 2 equation. Anywhere on the line, y is always equal to 2 no matter where you pick. And that's why we go with y equals 2 for our equation. They don't come up very often, but it's good to be aware of horizontal and vertical lines and how they work. But they also kind of lend us to a discussion about intercepts. So let's talk about what those intercepts are and define them a little better. Intercepts are where the graph or the picture of solutions crosses the x and y axes. So if I've got a graph here, let's say we're going to cross right here and right here, and there is our graph. The horizontal axis is the x-axis. The vertical axis is the y-axis. So we're crossing the x-axis at -1, 2, 3, 4, 5. X equals -5 is the x-intercept. And sometimes we'll express it as an xy coordinate, which would be -5, 0. Now here we see we're crossing the y-axis, the vertical axis, at y equals 2. That becomes the y-intercept. Now because there's no horizontal motion, this point becomes 0, 2. 0 to the left or right, but 2 up. So if we're using those terms x-intercept or y-intercept, that's what we're talking about. But the key things that we're doing today is taking a look at how we can build an equation from a graph, or how we can come up with the graph from the equation by identifying the slope, rise over run, and the y-intercept, or starting position. Take a look at practicing these on your own, and let me know if any questions come up.